In this video, we will look into locus and its equation. There are total 16 questions that I have planned, but these are very basic questions. The reason being this is a very basic concept and applicable for any kind of curve, be it circle or conic section or straight line. So we will try to understand the basic of locus in this video and try to solve basic questions where mostly these are related to elimination kind of thing. Let me write the concept first, then I'll explain. Alright, so the locus of a moving point is the path traced out by it under certain geometrical conditions. For example, if I say if a point moves in a plane under geometrical condition such that its distance from a fixed point O is always constant. So if this is the point O, and if I say the point moves in a certain manner that the distance from this point O is always constant, right? Let's say this is A. So what will be that curve? That will be one circle, right? That's very obvious. So there are different situations where the curve will be different given the condition, right? What was the condition here? The distance from that point is always constant. If you see in this kind of questions, always conditions are given. For example, number 4, find the equation of locus of a point such that sum of its distance from 2 points is 6. Question could be difference of its distance from point this and this is 6. Distance is constant. Find the locus of a middle point. Find something like the distance is equal to some constant plus x coordinate. Find the locus where the area of triangle is some number is given. Alright, so this kind of things will keep coming and there are unlimited kind of questions are possible. So let's understand the fundamental how to approach these kind of questions and solve it. The simplest locus example is if I say find a locus of the point which is always distance A from origin, right? So how to solve this? This P is moving point, right? The locus is always the curve traced out by the moving point. P is what? P is moving point. So locus is nothing but the curve traced by point P. It could be this, it could be this, it could be parabola, it could be straight line, anything. To solve it, what we do, we take the point as alpha beta. You can take H or K also. In fact, you can take X and Y also. But you can do this if there is no other X, Y in the question so that you don't do any mistake. So if I take this as alpha and beta, what is the constraint? The distance from origin is A. So you can apply distance formula, right? Alpha square plus beta square is A square. Alpha and beta you can replace with X and Y. X square plus Y square is A square. This is the answer, right? Because this is the variable alpha and beta that is varying and you have to trace out the curve and the equation we write in X and Y plane. That's why we replace that term with alpha X and Y. Alright, another example would be simplest. The distance from X axis is always 5. What will be that line? That line would be straight line, right? 5, this and this, right? The distance is always 5. The equation could be y equals 5 and y equals -5, right? This is also locus. If I say the distance from y axis is 5, the locus will be this line and this line, right? X equals 5 and x equals -5 and so on. So there are so many possibilities. What we have to understand here, we need to define some term, define this point alpha, beta, or h or k, or whatever, you can take anything. And based on the constraint, you can introduce any new variable also. If you see the questions, there are possibilities where you will have some variable things, right? Here cos theta, sin theta. So the first situation is already any variable is given, like here theta, right? So you have to eliminate this variable. The other possibility is that you yourself define some variable. You define something like p, you define something q or r. You have to eliminate those all things, and at the end the term or the equation should be in terms of alpha and beta only, so that you can replace it easily in x and y. First question is, if the coordinate of a variable point p is a cos theta, b sin theta, where theta is a variable, find the locus of p. In fact, I think 1, 2 and 3 are just the elimination problem, and later on there are little bit complex problem. I would not say complex because the complexity will come when we will move to advanced topics and try to solve the locus problems. X and y is already given. Point P is given. What is that? A cos theta and B sin theta. That means this is your X and Y, right? So you just write X is A cos theta, Y is B sin theta, and ultimately you have to eliminate theta, right? Because that's the variable. Curve will be traced by putting different values of theta, right? Theta is 0, theta is 45, theta is 90, so on. So you will get one curve. We don't know what is that curve. You can try to figure out by putting some values. You can try yourself plotting this curve, and finally whatever answer you will get, you try to plot that as well. That should match. So X is A cos theta, Y is B sin theta, and you have to eliminate theta. How to solve that? You simply, right? Cos square theta plus sin square theta is 1. So you can use this identity to solve this. Cos theta is what? X over A, and sin theta is Y over B. If you take sin square theta plus cos square theta, this will be y square over b square plus x square over a square is what? 1. So this is the answer. Let's try to plot that curve and see how does that look. X square over, let's take some number, maybe 9, plus y square over 64 equals 1. You see this curve, right? So this is the curve, famous curve, that is ellipse. We will get to know about this more detail, but this is how the locus of point P will look when we put different values of theta. Second question is, find the locus of a variable 80 square 280 where t is a parameter. So again, elimination problem. You have to eliminate t from x and y. So the point is, moving point P is 80 square 280. So x is 80 square, y is 280. How to eliminate? Just get the value of t in terms of y over 2a, and put it here, and we are done. X is a times t square means y square over 4a square, a cancel out, so y square is equal, not cancel out, one power will be cancelled out, y square is 4ax. Moving to third question, if the coordinate of a variable point is cos theta plus sin theta minus cos theta, where theta is a variable quantity, find the locus of P. Again, similar question, you have to eliminate theta from here. X is sin theta plus cos theta, and y is sin theta minus cos theta. You have to just eliminate, what is the target? Eliminate theta and get equation in x and y only. How to do that? If you see this carefully, this is in terms of a plus b, a minus b, right? If you make a square of these two things, you will get equation in a square and b square terms only. A times b term will be, ab term will be cancelled out. So let's try to do that. X square plus y square will be what? 2 times of sine square theta plus cos square theta, right? This is 1. So this is the solution. X square plus y square equals 2. Easy question. Let's move to number 4. Fourth question is, find the equation of the locus of a point such that the sum of its distance from 2 points 0, 2 and 0 minus 2 is 6. So this is the constraint. And always remember, the question of locus are not straightforward. You have to think over the problem because there is no formula where you can put the values and get the answer, right? So you have to use some variables, and there is not just one way to solve a problem. There could be 3 or 4 ways to solve a problem. Sometimes you can use trigonometry, sometimes you can use normal method without introducing any variable. 2 points are given. Let's say point A is 0, 2 and point B is 0 and negative 2. Alright, and it says, tell me the locus of a point, the equation of locus basically, such that the sum of its distance from this point and this point is always 6. Always 6. So this is what? This is constraint. And since we are in the coordinates, still not started straight line where we can use different methods like slope and those things. So mostly here I have kept the question where you are already familiar with the concept, like what? Like distance formula. You can use section formula, basics of geometry also, and area of triangle that you can use, those kind of thing. Alright, so it says sum of the distance is always 6. If this distance is 6, the point was P. Again, let's say again P moved here, and again if the sum of distance is 6, so this is how it will make some curve, right? This, I don't know what is the curve. That's the objective that we have to figure out. So we can apply distance formula here because it says sum of distance is 6. And we can directly use x and y because there is no xy given here already. So you don't need to use alpha and beta and then replacing it with x and y. Distance AP is what? Let's say this is x and y. So x square, x minus 0, right? Distance formula. And y minus 2 square. This distance equals, plus another distance, that is also x square. The x coordinate is 0, so x square plus y plus 2 square is what? 6. Take this other side, x square plus y minus 2 square equals 6 minus x square plus y plus 2 square. And I'm not going to do the calculation. You can just do the square both side, right? So this term will go away and you can square it, and finally you will get one answer that I'm just writing it, and you can match it. So final answer will be x square over 5 plus y square over 9 equals 1. This is the equation of point P given this condition. Alright, moving to next question. A line segment AB of length A plus B moves such that its extremities A and B always remain on axis of x and y respectively. Find the locus of a variable point P on AB such that PA is A and PB is B. So let's try to visualize this. One line segment AB is given, 2 endpoints are given, A and B. The length is also given. So let's note down what things are given. AB is given, length is given, that is A plus B. What else we have? And it describes the motion of this line, extremities A and B, the endpoint AB always remain on axis of x and y respectively. So this point will always be on x and y axis, right? So this constraint is also given, and there are multiple ways to solve this question, right? So this constraint is given, and what is, find the locus of variable point P on AB, P, this point, such that PA is A and PB is B. So this constraint is given, and the endpoints are moving, right? Initially maybe line was somewhere here, it is moving in this way, it is going this way. So this point is moving. The endpoint A and B are variable, and the midpoint, it says locus of what? Locus of variable point P such that PA and PB are A and B. So it is not talking about midpoint or something, it always says the point which will divide in ratio A is to B, right? So I'll tell you two methods to solve. In all cases, try to keep the unknown variable minimum as possible, because if you take two variables, you need to solve too many equations to eliminate those, right? Ultimately, what locus is all about elimination and thinking how to put things together based on the constraint. That's the locus. So let's put this and try to solve. X, Y, line segment AB, A and B. We know point P is, let's say this point P. This divides into A into B ratio. Also the length is given A plus B. Okay, so what we can do here, this thing is moving, right? This thing is moving. So we can think of this angle also as one variable, right? Because this is moving. Whatever is moving or whatever is changing, you can put those as variable, right? So variable is unknown quantity or changing, whatever is changing, you have to put that. Like here, it could be angle, right? Or it could be coordinate of A and B. So let's try to put first these things. Like A is, suppose I'm taking it as x coordinate will be 0, y is k, this is h 0. So this is unknown variable, these are variables h and k which is changing. Finally we have to solve in a way so that answer will have just x, y and some given constants like a and b. This is constant because a plus b is not changing. The length of stick or length of this segment is never changing. So what can we do here? First we can apply section formula, right? A and b is given. So to figure out the point P, I'm directly taking it as x and y, but you can take it as alpha, beta, and later you can change it to x and y also. So if this is A and B, x will be A times h, right? A times h, b times 0 over A plus b, and y will be similarly A 0, so this is 0 bk over A plus b. Now what? We got it, right? X and y, h and k. There is one more thing here, right? The distance is given or the length is given A plus b. This is h, this is k. So you can apply Pythagoras theorem also. So h will be A plus b x over A, and k is A plus by over k. Why we are doing this? Because we can, once we have h and k, and another thing we can think over, like we can apply Pythagoras theorem, right? H square plus k square is this number A plus b whole square, so that the final answer will be x and y. Ultimately we have to do elimination, right? So let's put that h square plus k square is what? A plus b whole square. If you put like I have space crunch, alright, so h is what? A plus b square over A square plus k is what? K is A plus b whole square, y square over, this is not k, this is b. B square is a plus b whole square. This will cancel out, means this will become 1. So the answer is what? X square over a square plus y square over, no, this is PA was what? PA was a, PB was b. So I think I did one mistake. Here it was saying a is lying on x-axis. A was lying here and b was lying on y-axis. So you have to interchange this. But you got the concept, right? So if a was lying on y-axis and b was lying on x-axis, the equation answer will be x square over a square plus y square over b square equals 1. This is the answer. But let me do that also. We can simply, let's do that. A is lying on x-axis, right? So a, b, this point p is xy. This term was PA was a, this was b, 0 h0 and 0k. X will be b times h, right? B h over a plus b, and y will be b times, not b times, a times k over a plus b. So h is a plus b over b times x, and k is a plus b over a times x. H square plus k square will be a plus b square over b square x square plus a plus b square over a square y square equals is a plus b whole square, right? This distance a plus b. So the answer will be x square b square plus y square over a square equals 1. This is the correct answer as per this questions. But if you change the a and b to different x's, you will get the previous answer. So this is the answer. There is another way to solve it. Instead of taking two variable, you can just use one variable. Okay, the variable was h and k. Let's take theta because this line is sliding, right? And the angle is involved. Let's try to solve that. I hope I won't do the same mistake again. A and b. B, this is a, other is b. Okay, this is a, let me use this. This segment is a, other segment is b. And if you think this as variable, right, this theta is changing, this is sliding here, this is going this way, or in fact it can go like this also. If you take this as theta, what is given here? Let's assume this is x and y. All that you can take is alpha and beta, and finally you can change it to x and y. That is also you can do. So x and y is given. So this point, this is y, and this is x. This is also theta. So if you see this carefully, what relation we can derive? Theta is given. The perpendicular and this hypotenuse is a. So you can write it as sine theta is y over a, and here cos theta is, why I'm taking cos theta, because I'm taking base here. Cos theta is x over b, and once this is known, you can simply say x square y square over a square plus x square over b square is what? 1, right? Because sine square plus cos square theta is 1. Is it matching? Y square over a square, x square over b square is 1. Alright, so this is neat way to solve by using just one variable. If you take two variables, the calculation is little bit lengthy. Question 6. If O be the origin and A be a point on the locus y square equals 8x. So when we say locus y square equals 8x, that means it's an equation, right? Everything is locus only. Find the locus of middle point of OA. So let's draw that. Question 6. And the interesting thing is we don't need to understand the nature of graph, right? It says y square equals 8x. So suppose there is some curve, okay, like this way, and this is the locus, right? Locus of what point? Every point which is lying on this curve, let's say P, right? This is another P, this is another P, like this. All right. O is the origin and A be the point. Let's name it A. So this is OA. And we need to find the locus of middle point of OA. When this A will move on this equation or the locus, what will be the locus of this point? Let's say this is P. P is the midpoint. So if you take this as alpha beta, this will be some thing, right? Alpha by 2 and beta by 2. This will make the calculation difficult because we have to replace alpha by 2 and beta over 2 to x and y, right? So what we can do here, instead of taking this as alpha beta, we can take P as alpha beta and finally replace with x and y. All right, so let's take this as alpha and beta. If this is the midpoint, what will the point of A? That's very obvious. We can say alpha 0 plus some number like P over 2 is alpha, right? So P is 2 alpha. So this is 2 alpha, this is 2 beta. And this point, what can we do with this 2 alpha and 2 beta? This will satisfy this y square equals 8x, right? So just put that y is 2 beta square 8 times 2 alpha. So this is 4 beta square equals 16 alpha, or this is 4. So beta square equals 4 alpha, and just put x and y instead of beta and alpha. So equation will be y square equals 4x. This is the answer. Let's move to next question. Question number 7. If A cos theta sin theta, B sin theta cos theta, C 1, 2, 3 points are given. Obviously theta is a variable that will vary. So these are not fixed point. A and B are varying. Are the vertices of triangle ABC. Find the locus of its centroid if theta varies. Question 7. ABC are given. A is cos theta sin theta. B is sin theta cos theta. C is 1, 2. This is fixed, right? This is fixed. And theta is variable that we have to eliminate, right, to get the locus. All right. When we put different values of theta, this point will keep moving, right? A and B is not fixed. So obviously the centroid will also vary, correct? So centroid is obviously the average of all 3 points. X coordinate of centroid will be, I'm just putting x instead of alpha and beta. That will be sin theta plus cos theta, right? Sin cos plus 1 over 3. And y coordinate of centroid will be sin theta plus cos theta plus 2 over 3, or this can be written as 3x equals sin theta plus cos theta plus 1, and 3y is sin theta plus cos theta plus 2, right? To eliminate theta, what we can do here, we can just subtract 3x minus 3y equals -1, or 3x minus 3y plus 1 equals 0. This is the answer. This is straight line. And we are done with question number 7. Let's move to 8. Question 8. A and B are two given points whose coordinates are -5, 3 and 2, 4. So these are fixed, right? A and B are fixed. A point P moves in such a manner that PA is to PB is 3 is to 2. Find the equation of the locus traced out by P. So let's draw. Question 8. 2 points are fixed, that's A. Another point B. A is -5, 3, and B is 2, 4. Point P, I don't know where is that, but we can directly put that point as X and Y. And the condition says PA over PB equals 3 over 2. The ratio of these two distances 3 over 2. So obviously this is not one point. This will be some curve. We don't know. We need to figure out. So this is very simple question where we need to use distance formula, right? So PA over PB equals 3 over 2. So PA is what? X plus 5 square plus y minus 3 square. This one over x minus 2 square plus y minus 4 square equals 3 over 2, and do the squaring on both sides. Finally you will get the answer. I'll give the final answer and you can match it. 5x square plus 5y square minus 76x minus 48y plus 44 equals 0. So this is done. Let's move to question number 9. Question 9. A stick of length L slides with its ends on two mutual perpendicular lines. Find the locus of middle point of the stick. So again, I think we had solved one problem, right? Similar to that. Obviously, when two perpendicular lines are given, we will take x and y axis. Alright. The stick length is L here to here. And we need to find the locus of middle point when this is sliding on this perpendicular wall or whatever you call these axes, right? So let's define two variable the way we did last time. Two ways to solve, either take theta or two variables. So if I take this as 0b, 0a, and finally we need to eliminate, right? Final terms would have L, X and Y only, no A and B. And since we have to find the middle point, locus of middle point, let's name it P and give alpha and beta. So alpha is obviously middle of this. So alpha is not 0, 8. This is A0. Alpha is A over 2, right? And beta is obviously B over 2. And also one important fact is A square plus B square is L square. So we need to actually make it alpha and beta, and finally we will replace it with X and Y. So A is what? 2 alpha. So 2 alpha square plus 2 beta square equals L square. 4 alpha square plus 4 beta square equals L square. So this becomes 4x square plus 4y square equals L square. This is the answer. Question 10. We have around 7 questions more. S is the point 40. Alright, this is on x-axis. M is the foot of perpendicular drawn from a point P to y-axis. If P moves such that the distance PS and PM remains equal, find the locus of P. So already one point is given. That point is on x-axis. That point is S 40. And M is the foot of perpendicular drawn from a point P to y-axis. So P could be any point. Let's say this is P. And we need to find the locus of P, right? So P will be obviously alpha beta. Let's name it. And M is the foot of perpendicular. Also something else is given. Distance remains equal. So P moves such that distance PS and PM remains equal. PS is what? PS we don't know, but PM is very clear. PM is what? PM is alpha, right? So obviously this will also be alpha. So if this is alpha, so alpha minus 4, this distance, plus beta square is obviously this square, right? Alpha square, and we are done. We need to just substitute x and y and we are done. Alpha square plus 16 minus 8 alpha plus beta square is alpha square. This is cancelled out. So beta square minus 8 alpha plus 16 equals 0. Just put x and y square minus 8x plus 16 equals 0. This is the answer. Let's move to next question. Question 11. Question 11. If a point P moves such that its distance from A0 is always equal to A plus x coordinate of P. So A0 is fixed point. So that the locus of P is y square equals 4ax. So let's draw this. This all are related to distance formula only. Question 11. So one point is given, A0, right? A0 is given, and point P moves such that distance from this point, distance from P is somewhere here, this distance is what? Equal to A plus x coordinate of P. So if we name it alpha and beta, distance is same as A plus alpha. Alright, so just apply the formula and we are done. Alpha minus A square plus beta square equals A plus alpha square. So alpha square plus A square minus 2A alpha plus beta square is A square plus alpha square plus 2 alpha A square. These are all cancelled out. What is left? 4A alpha equals beta square, or y square equals 4ax. This is what I think we had to prove. Y square equals 4ax. Let's move to next question. 12. If A fixed point and B are two fixed point, find the locus of a point P so that the area of PAB is 9 unit. Question 12. If A is fixed, A is 1 1 and B is negative 2 3. These are two fixed point. And what is moving point? Moving point is some point P, alpha beta. And what is the constraint here? Constraint is area of triangle is 9 unit. All right. So this is also a very simple question. You need to just apply the area of triangle formula, but just be careful that area of triangle is always mod of 1/2 of formula is this one, right? x1 x2 x3 y1 y2 y3 1 1 1. This is the formula. All right, so this becomes 1 by 2 alpha 1 negative 2 beta 1 3 1 1 1 equals what? Plus minus 9, right? Or you can say mod of this is 9. This will become plus minus plus alpha 1 minus 3 is 2, so negative 2 alpha negative beta 1 minus plus 2, so this will be 3, and 1 3 plus 5 equals plus minus 9, or negative 2 alpha minus 3 beta plus 5 is not 9. Okay, 1/2 of this is plus minus 9 or 18, or you can say mod of this is 18. So two possibilities there. Just replace with the x and y. 3y plus 5 equals 18. So negative 2x minus 3y plus 5 is either 18 or minus 2x minus 3y plus 5 is negative 18. So this becomes 2x plus 3y equal 5 minus 18. 18 minus 5 is 13. So plus 13 equals 0. This is one line, and another one is 2x plus 3y, 18 minus 5 minus 23 equals 0. So these are the two answers. Let's move to next question. Find the locus of a point such that line segment having endpoint, these 2 points, subtend a right angle at that point. So whenever there is a right angle, there are two possibilities. Either you have to apply Pythagoras theorem, or if you are learning straight line, you have to use some concept of slope. But we have not learned slope, right? So probably this will be related to your Pythagoras, right? So let's draw that. Two fixed point, and third point is making such a way that it is right angle. Question 13. So 2 points are given, 2 0 and negative 2 0. The point P, let's say alpha and beta, is making right angle, and whenever it moves, it is always making right angle. So if you're familiar with this circle in your basic geometry, the locus will be obviously circle, because it makes 90 degree wherever you move on this. But anyway, let's try to figure out what is the equation of that circle. So distance is, again we have to apply distance formula, alpha plus 2 square plus beta square. This distance, square of this one is square of this one plus square of this one is same as this one. Alpha plus 2 plus beta square plus alpha minus 2 square plus beta square is 16. And if you simplify this, you will get alpha square plus beta square equals 4, or x square plus y square equals 4. Obviously when you will read circle, this will be x square plus y square equals 2 square. So this is the circle. Anyway, let's move to next question. Question 14. If P is the middle point of a straight line joining a given point A1, 2, so one point is fixed, and Q. And what is Q? Where Q is a variable point on the curve x square plus y square plus x plus y 0. So obviously in the question of locus, things moves, right? One point is fixed. When other point is moving, what will be the locus of mid of that line? All right. So let's draw that. Question 14. One point is fixed. That's A 1 and 2. And other point Q is also varying, but it is lying on line x square plus y square plus x plus y equals, not line, I mean on this curve, x square plus y square plus x plus y equals 0. So this is a moving point, and this is fixed point, and mid of this will also be, let's say P. This will also be moving because this is moving, so this will also move. Where it will move, we don't know. How this will move, that is the locus, right? That we have to figure out. Let's keep this as alpha and beta. When this point is midpoint, so let's take this P and Q. That's easy to find. 1 plus P over 2 is what? Alpha. So P is 2 alpha minus 1. And for y coordinate, 2 plus Q over 2. That's just a midpoint formula, right? Q is 2 beta minus 2. And when this point is there, and we know this is lying on this curve, so we need to just substitute 2 alpha minus 1 square plus y is what? 2 beta minus 2 square plus x is 2 alpha minus 1 plus 2 beta minus 2 equals 0. This one y x plus y 2 beta minus 2. So I'm just giving the final answer. You need to substitute alpha to x and beta to y. So final answer is 2x square plus 2y square minus x minus 3y plus 1 equals 0. Now let's move to question 15. We have only 2 more left. From the point A6 negative 8, all possible lines are drawn to cut x-axis. Find the locus of their middle point. This is a little bit vague, but the intent is very clear. From point A, all lines are drawn. So let's draw that. Question 15. A point is given. A point is given, that is 6, negative 8. You have to draw. All possible lines are drawn to cut the x-axis. This is x-axis. So you draw this point, you draw this point. Keep drawing. Things are obviously moving. Multiple lines are there. And we have to find the locus of their middle point. Midpoint means locus of midpoint of what? Obviously it should be line segment only, right? It cannot be infinite line and midpoint. So we have to find the locus of midpoint of this. If this is the midpoint, if this point, this point, this point, this point, this point, this looks like one straight line, right? Let's try to verify that. How can we do that? Obviously this P point, we have to take alpha and beta, right? And x-axis, the value of y is 0. So it doesn't matter what is the x coordinate. Y will always be 0, right? And if this is the midpoint, obviously 0 minus 8 over 2, the average of this 2 point is equal to beta, right? So 2 beta is negative 8 or beta is negative 4. If you put this as y, that comes y is minus 4, and y equals minus 4 is what line? Obviously this line. You see this? So the P is moving like this. Even if you're making so many lines, P will be constrained on this line. So y equals negative 4 is the answer. The last question is find the locus of the midpoint of the portion intercepted between axes by line x cos alpha plus y sin alpha equals p, where p is constant. Question 16. So what is the equation of line? It says x cos alpha plus, anyway we are going to start straight line from next chapter. P is constant. Alright. So we don't know what is the value of, or how does this look, straight line, but let's assume this is the line, right? X cos alpha plus y sin alpha is p. Any line, this can be written in this format, x and y. Let's assume the question says locus of midpoint of the portion intercepted between axes. So x and y axis, let's say this is one intercept, this is another intercept. We have to find the locus of this point P. We can take it as alpha and beta, but since here alpha is used by this straight line, so we can take it another variable m and n, that we have to replace by x and y later. And since this is midpoint, so this is very obviously we have to apply the midpoint formula. So x intercept will be 2 times of that, 2m0, and this will be y intercept will be 0 and 2n, right? That's why you will get, right, 2m over 2 is m and 2n over 2 is n. So these points are given, and equation of line is also given, so we can try to put this value because these are lying on the line itself, right? These 2 points. These 2 points are on the line, so we can just put the values 0, 2 and so when x is 0, y is what? 2n sine alpha is p, right? And when x is 2m, y is 0, so that's also p. Now we have to eliminate what? Eliminate alpha, right? Because answer should be in terms of m, and that's ultimately x and y, and what else is given? P. So it should have only m, n and p. How to figure out that? It's very easy. Sine alpha is p over 2n, cos alpha is p over 2m, and you already know sine square alpha plus cos square alpha is 1, so you can put that. P over 2n square plus p over 2m square is 1, or 1 by 4 n square plus 1 by 4 m square equals p square. We can bring this side, or in fact 4 also you can put this side. So x and y, so answer is 1 over x square plus 1 over y square equals 4 over p square. This is the answer. This is all about locus. In the next video we will be studying straight line. See you in the next video. Bye.